Okay, good afternoon. Actually, no, good evening, ladies and gentlemen, or maybe good morning, ladies and gentlemen, depending on where you're at. Today, we are going to take a look at the Berkeley Math Tournament, and this is the calculus test from 2013. For more information, of course, you can go find it in the description, such as more past exam questions, and also this year's competition is going to be held at UC Berkeley campus on November 2nd, and I will be there as a guest. So I'm not going to participate in terms of like compete. No, I'm not. But today we are going to take a look at the calculus test from the previous year, and let's see how this is. All right, I'm not going to solve the questions though. I'm just going to kind of show you guys how the questions are. And let's go ahead and get started. And hold on, I'm also going to set up another phone on the side so I can kind of read the comments. Let me just make sure. All right, so for this test, we have a total of 60 minutes and then 10 questions. And perhaps I'll zoom in a little bit more like this. All right, so for this, mostly will be just computation. So the answer are just going to be numbers. And then it's going to get harder, of course. And no calculators, of course. All right, so let's take a look at the first one. All right. For the first one, we are going to compute f prime of pi over 4. And then we have f of x equals 20 cosine x plus 23 sine x. Well, because 20, 23. So I would say the first one is just like straightforward. As long as you have taken and remember calculus, then this right here shouldn't be a big deal. And of course, know your trig values and all that good stuff. So that's it. So straightforward. And then for the second one, we're going to compute this integral going from 0 to 4 and then x minus 2. And that's the trig right here. The input is all x minus 2. The powers are different, of course. But I will say do a quick use up, and that should be pretty straightforward as well. Now let's move on to number 3. Let's move on to number 3. Sorry about adjusting the lighting. There we go. So it gets a little bit wording, a little bit wording, but it's not bad. We are going to find. We're going to let A be the area of the region bounded by x equal to 0, y equal to 0, x equal to 6, and then this curve, square root of kx. And k is just some positive real number. And if we know the region has the area 36, we are going to compute the value of k. So set out the integral, right? Because the integral will help you to find the area under the curve. And then you are going to set the integral equal to 36 and then solve for k. So pretty straightforward as well, I would say. So far, the first 3 questions are just pretty straightforward. All right, and then just do the math. You should be able to finish it in a reasonable amount of time. Now, for number 4, this right here, it's a related rate question. I am kind of surprised that they have a related rate question like this. It kind of reminds me of like AP exam. So he says an ice cube melts in a way such that it will always remain a cube, and its volume decreases at a constant rate. Initially, each side length is 10 inches. It takes 15 minutes for the ice cube to melt completely. When the side length of the ice cube is 4 inches, we would like to know the rate in inches per minute. The side length of the ice cube decreasing. So related rate, right? Related rate. I can actually put this question on my like a calculus 1 test because it's just a related rate. Or maybe I can demonstrate this in class. Okay. So for that, not so bad. Alright, let me take a look at the chart. Alright, so for the people who are just joining, thank you guys so much for joining today. Today we are going to just take a look at the calculus test from the Berkeley Math Tournament from 2023. And then right now we are going to go to number 5. Okay. Alright, so for number 5, we have this function f of ab. This is b cubed minus a cubed plus a squared b minus ab squared. There exists a real number c such that regardless the choice of non-negative real numbers, and it's a list, right, going from x0 to xn, from smallest to the biggest, in fact from 0 to 4. We have that c is always going to be less than or equal to the series as I goes from 1 to n, f of xi minus xi. We would like to compute the maximum value of c. So for this one, I'll pause for a little bit. Let me know what you think for this right here. Let me know what you guys think right here. And then in the meantime, I'm also going to take a look at the chart. So hello everybody. Alright, so right now we are on number 5, right? Alright, hello everybody. I haven't done a live stream with you guys for a while. And today we're taking a look at the calculus test from the Berkeley Math Tournament, which is in about, well, 2.5 weeks. I'm excited to go back to UC Berkeley campus. Yeah, I will be there as a guest, right? Not to participate. Yeah. I do teach at a college here in the US. Yeah, in real life, so it's not just on YouTube. Alright, could you factor f of ab? Very good observation. This is b cubed minus a cubed, looks like it, and then this is like a squared b minus ab squared. So it kind of reminds me of like some expansion, right? So you can try it. So for this one, you have to know the structure of the question. And once you know it, in fact, the work is actually very easy, but I just have to understand the math behind such wording for number 5. So I'm going back to the chart and just like reading what you guys said. Why is there such a difficult spike from Q4 to Q5? Well, that's how math competitions are. Yeah, so for this one, what do you guys think? Here's a hint though, if you I don't want to mention the object yet, but if you have seen like this kind of things right here, then you should recall where do you see this in Calculus 1 class, usually toward the end. Find a critical number? No. Usually, if you want to find min-max, right, you want to find critical number, you have to take the derivative, but not this one. Yeah. And John, you got it right. The answer is this has something to do with Riemann sum. Yeah. Perhaps the hint is right here. Join the triangles and then set out the partition for the x. And then you see that x0 is 0, xn is 4, so Riemann sum and yeah, integration, and you're going to go from 0 to 4. But what's the function though? What's the function that are we really focusing on? And why is such a thing like this? So for this one, the computation is not bad at all, but you just have to understand what the question is asking. All right, so let's see, treat A and B as two separate functions. I don't know if that will work. Again, the hint is that this has something to do with Riemann sum, and of course, to compute Riemann sum, we can convert that into an integral and then compute the integral instead. I do have the solution, so maybe another minute or two, and I'll show you guys the solution. Okay, so for this function, yes, we can factor it, b minus a. Yes, if you factor it, let me just put down what you put in the chart right here. B minus a times a squared plus b squared. That is the correct factoring. Well, the key right here, again, is that you have to know what this setup is for. And it is about Riemann sum. And once again, try to find the corresponding integral that will help us, and then see what this is really doing. So once we factor it, then what do we realize? And yeah. The maximum of C is not equal to 4. Yeah, because we do have this function that's like happening like this. Okay, so Zhang Yu said it's 2 times the integral of x squared from 0 to 4. Close, very close. B minus a becomes dx. Not entirely. And not entirely. I would say not entirely. And I will tell you, this is not really like a Riemann sum in the usual sense, because it's not really using rectangles, right? And in my opinion, this is actually a pretty good question, because yeah, you'll see. It's not really about rectangles. Trapezoids, that is correct. And Zhang, you are very, very close. It's not 2 times the integral of x squared from 0 to 4. Unless I misunderstand what you are trying to say for that, because now what would your final answer be though for this question here? What would your final answer be for the maximum for your C right here though? Use a calculator. Even though, well, actually no, don't use a calculator because this integral is pretty quick to compute. I was going to say just use the calculator for the computation during the live stream to save time, but this one is not bad either. So yeah. So I'm also looking at the chat and then I'll be replying. And in a moment, yes, we are looking at number 5. We're doing number 5 and we are almost done because John had a very nice observation. And right now we're just waiting for the final answer. Right? We want C. So you can, if you just join it, you can kind of screw up. I think you can still see the previous chat and you can see the comments from earlier for our discussions. Why are we waiting for the final answer? Well, I'm just kind of giving you guys some time to try. Oh yeah, hey, John got it. That is correct. Indeed, that is correct. So let me show you guys the solution here. All right. So you can factor it, and then you can kind of like recognize it. It's in this form. It's a Riemann sum, and this right here is actually the trapezoidal integral. So it's not the rectangle business that we usually do. Yeah. Very nice question because we don't really put like trapezoids to structure an integral that often. Yeah. So I think maybe this right here is a great hint, right? 0 is equal to x0 and then all the way to xn, which is equal to 4. And yeah, and then draw some pictures that will be helpful. And at the end, you just have to compute this integral and then you get 128 over 3. Okay, now let's take a look at number 6. So for a positive number x, we define the function. The first one, well, f0 is 1 over x. And then fn is just the nth derivative of 1 over x. N is a positive integer. And we are going to define g of x to be the sum as n goes from 0 to infinity of 1 over f sub n of x. And we are going to compute g of 1, not 0, why I'm saying 1. G of 1. So for this one, it requires some Calc 2 stuff because not only we have the infinite series, but you also have to recognize some kind of specific series. By the way, this is the calculus test from 2023. I'm not sure how 2024 exam will look like. I'm not sure about in terms of the difficulty or similar questions or whatever. Right? Because for math competitions, you just go there and enjoy the questions. Yes. All right. So John once again said something involving E. Okay. And then Jay, you say Taylor series. Yes. And Mosk thinks the next one, this one is 1 over e. How come? How come this is 1 over e? Yes, I think you guys all got it. Yes, because this right here turns out to be x times e to the negative x. Right? So you have to differentiate this a few times and then to see a pattern. Right? Write this as x to the negative first power, and then just differentiate a few times, and you will see that there's a -1 and then to the nth power. So in fact, you will get an alternating version of that, and the answer is 1 over e. So that's the solution. Yeah, differentiate this a few times and then put it here and then kind of reorganize, fix it. And the key right here is to recognize that once you do so, you have x times this series, and this is e to the negative x. Because again, the alternating part, the -1 times x and then to the nth power, so that. And then you can just put down, you can just enter 1 into x and you get 1 over e. Yeah, this right here requires some calculus too, especially usually toward the end. Yeah, usually toward the end of calculus too. All right, so I'm going to just kind of like see the chart, and then one person says, may I ask, what would all the prereqs be for joining a competition like this? Do you mean the knowledge-wise, or do you mean the requirement in terms of like how can you sign up for the competition? This right here is going to be held at UC Berkeley campus this year in November 2nd. And there's also going to be online version. So if you are interested, you can check the website. The link is in the description. Yeah, this right here, you will see the series in Calc BC, a Taylor series for e to the x. Yeah. Now, number 7, in my opinion, this right here is pretty technical. I think you really have to learn the method, like for like a math competition, in order to solve it. Technically, discrete math, so it's not usually taught in like algebra 2, pre-calc, or so, depending on. So we are going to have a sequence, right? A0, A1, so on, so on, so on, and then we know A0 is 24 and A1 is 23, and we have a recurrent relation, right? An plus 2 equals negative An plus 1 plus 6An. And then once we have this, we're going to compute another infinite series. But we have to put An right here and then clean this up. So I can work this out for you guys real quick, just to maybe you can see a pattern, but it's hard if you just want to like look at the numbers and see a pattern. A0 is 24, so we have 24. A1 is 23, and then next we will have to do negative the previous one. So right here we will have to do negative 23 plus 6 times the previous one, previous, so 6 times 24. So that's 144, and then minus 23. So that shall give us 121. And then for the next one, you're just going to follow this recurrent definition. So if you look at the numbers right here, it's extremely difficult to look at this and try to figure out pattern. You really need to have a systematic method to go from here, along with the initial conditions, to find out what An is in terms of an explicit formula. And if you know the method for doing so, this question is not bad. But if you don't, then it's, of course, like impossible in my opinion. Oh wow, you guys are really fast. Something times ln of 3 over 2. Yes, I will tell you yes. I'm looking at the answer, so yes. And if you have r squared plus r minus 6 equal to 0, yes. That is exactly how you are going to do it. Alright, so yes, we do have the an formula from John in the comment. So I'm going to just talk about this real quick because this right here, it used to be one of my favorite topics in discrete math because it's very similar to a second order linear differential equation with constant coefficients, very similar. So what you want to do first is you want to start with a general form for an, and because these are all constant coefficients, so an is going to be in the form of some ratio r for the base raised to the nth power. And you might be wondering why. Well, I'm going to write this down right here. For example, this is just an example. If we defined an plus 1 to be, let's say, 3 times the previous, let's say it's just an, then this means you just always multiply by 3, right? 3 times the previous, 3 times the previous, and so on. So based on this, you can figure out that an is going to be 3 to the power of n. And depending on the initial condition, we will have some coefficients right in the front. And if you have more terms, in fact, it works the same as well. But we just had to find out what the base is. So an equals r to the n. And let me see if you can fit this in. Next, an plus 1 is just r to the n plus 1. an plus 2 is just r to the n plus 2. And then we plug into this equation. So we are looking at r to the n plus 2 equals negative, this right here is r to the n plus 1, and then plus 6r to the n. Now, if r is equal to 0, of course, that is just game over. Like nothing's happening. So we don't want r to be 0. That means we can divide everybody by r to the n. And then this right here gives us r squared. And then this right here will give us negative r. Move it to the other side, so minus r. And then this right here will give us 6. Move it to the other side. Solve this by factoring r minus 3, r plus 2. So r is equal to 3, r is equal to negative 2. Once we have this, you know an will be in the form of 3 to the n plus negative 2 to the n. But we will have some coefficients. You have to use the initial conditions to figure it out. Let me put down alpha and beta. So plugging 0 into the n, and then plugging 1 into the n, and then set up a system of equations to figure out alpha and beta. So that's how you solve this kind of equations in general. And once you have that, you can put in here and simplify the series. And again, you have to recognize what infinite series that you have. And just to save time, here is the solution. Well, actually, did anybody have the answer already? I know somebody said it has to do with ln of 3 over 2. That's great, but then what times ln of 3 over 2? Okay, chemistry test tomorrow. Wish you luck. And thank you so much for the super chat. Well, I think that's called super thanks. Thank you. It's not 47 over 6. It does have the ln of 3 over 2 somewhere. So you have to recognize what power series that we'll end up with. So again, once we have this, put it here, and then clean things up. And the reason that we end up with ln was whatever, it's because of the n on the bottom. So it's not a geometric one. The answer is about 5.67. Well, we cannot use a calculator for that. Okay, let me see. John, you have negative 19 and minus. I think that's equivalent. Yes, you have an equivalent answer. I think the rule is that you should simplify the answer though, I think. Yeah, that's equivalent to this answer. So I'm going to just show you guys the solution here. So the final answer is ln of is 14 times ln of 3 over 2. So yeah, there we go. They use x and y for the coefficients, and then you just have to put that in. They put this form, right? An is this. Put that into the an, and then break it apart. Once again, because we have the n on the bottom, you will need to use ln for the Taylor series. Right, let me know if we are ready for the next one. So I'll wait for another like 30 seconds or so. Hello, you forgot to do the plus C. No, I didn't forget about the plus C. I will be going to BMT this year again and co-host the Integration B event. So this is how it works. Like in the morning and early afternoon, there will be examinations like this, right? And then the Berkeley students and the volunteers, shout out to them, they have to take time to grade the test for the students. And during that period of time, we have events for the students. And one of the events is Integration B, and I will be, co-hosting. So I will go there and say hi. So if you happen to participating, I will see you guys there. Okay, let's take a look at number 8. So here we have f continuous function, yeah? That's the domain, 1 to infinity. And we have this thing. We're defining I of f. So it's kind of like we use f as the input for this function. We know that this right here converges and is maximized over all continuous function, yeah, from 1 comma infinity to r. We are going to compute f of 1 plus I of f. You are doing number 9 instead. Number 9 is like if I am on the competition myself, I will really go with number 9 instead of number 8. Yeah, because I think I will have a better chance with number 9. Because yeah, we have to first understand what the question is asking, and of course, there are the technical parts. So we're looking at number 8. Any thoughts for number 8? Well, do you guys just want to look at the answer for number 8 right away? Yeah, number 8 is definitely not easy. Yeah, I would say number 8 has the most complicated answer among all the questions. Yeah. Differentiated. You don't have to. I think maybe work, because of course we're talking about min max, right? So if we differentiate it, maybe. I'm looking at the official solution. You don't need to differentiate. It will take too long if you do so. And I think, yeah, not sus. Like, you really got number 9 correct. Number 9 is indeed 5 pi. So number 9 is just perhaps a more computational question, just that you either you expand or you use trig identity and then just compute it, and then you end up with 5 pi. And have some patience and be careful. Yeah. But number 8 is that you have to understand what the question is asking, and yeah, how can we make this work? So give you guys another minute. Any thoughts? Is this some recursive integral idea? Not really. I don't think so. It's more like a functional, because the input's a function, and then instead of the integral. So the answer is not 42. It's not that nice of a number for this answer. Diffuse the power. What do you mean by diffusing the power? Number 8 is hard in the sense that you have to try to understand what the question is asking you, right? And of course, along with this hint, well, not this hint, this is like the problem, like what do you mean by maximize? So how can you structure something that will give you like a maximal? Oh, okay, so in the chat, like you guys are doing number 9 instead. Maybe I cannot really cover that up, but I cannot stop you guys from doing number 9. Your intuition is that the lower bound for I of f is f of 1. So we are really only solving the integral at infinity. But we don't know what the function is, right? We don't know what f of x is. Now this is definitely a hard one. It's like I have to look at the solution in order to know like how they even do it. And then to be quite frankly, it's like, yeah, I can't come up with the solution myself, and then it's hard. It took me a while to kind of see how it works. I maybe try Newton's method. I can ensure you maybe not Newton's method for math competitions, because usually for Newton's method, you will have to use a calculator. But sometimes that's a good idea if you will ever see Newton's method on like a math competition. Maybe in the more theoretical way will be extremely nice numbers. Number 10 looks easier than number 9. I mean number 8. Okay. I think we are done with number 9, and then number 10 is this integral along with this infinite series. Yeah, and then you are saying number 10 looks easier than number 8. At least we know like what this is asking, right? And then you can kind of work with it. And number 8 is like we don't even have a specific function. Right? F of x, we don't know what it is. Isolate f of x from here. How can we do that? Because we have this inside of the integral, and this integral goes from 1 to infinity, so we cannot just differentiate both sides and get rid of the integral. Does not work for that. Tell us the solution. Okay, 30 more seconds for the people who are trying, and then I will show you guys the solution. And if you really want to think about this on your own, then just kind of like turn this string off for a little bit for like 2 minutes while I show the solution, and then turn it back on after we are done with the solution. Okay, square root of 2023, it's just a distracting number, I think. It's just a distracting number. It's just a number because they wanted to put it there, I think. Break the integral into 2. Okay, and then how do we continue from there? Normalize it to 1. You mean you want somehow the result of this to be 1? Okay, so you said it's like ax squared plus bx plus c. Kind of like a good observation. Okay, and then let's see. Normalize it to be 1. I don't think it's necessary. It's not. No. Okay, so I am going to show you the solution. If you want to think about this question on your own, just kind of look away. All right, so here we go. Here is the answer. This is the answer. You see, the square root of 2023 is just like a distracting number. It's just there, right? It's just there. It doesn't really affect the structure of the answer. So let me see if I can show you guys everything on one page. Yeah, I think we can see this okay. So, like the first step, it's like, how did they come up with it? Or maybe you'll be thinking like, yeah, like how, right? Consider the function in this form for some a and b. If you expand it, try to match this with that. Right? Try to match with that. So definitely that's the hard part. I think I still want to zoom in. Sorry. There, I still want to zoom in, so it's easier for you guys to see. So start off with this, and then you want to kind of expand it and then match coefficients so you can get the a and b values. It's kind of like completing a square in another word, but in this kind of like way. So once you figure this out, you are going to put this integral into this form. And now this form has this, something minus a quantity square. And then you want this to be maximized, right? So in that case, you want this part to be 0, because it is minus, so you want this part to be 0. So you can continue from here. Let me see there. So that's how we figure out what f of x should be, right? You want this part to be 0. And then once you have the f of x, you can work that out. Yeah, I will have no idea how to solve this. By the way, they do have plenty of past exams on their website. The link is in the description. So if you want to try their questions, like BMT 2022, the GUTS problems, or the discrete math problems, geometry problems, it's all there, along with solutions like this. In fact, they didn't have a solution for this. They just put it up about like a week or two ago. Yeah. If it's on your test, you will skip it. I will skip it too, totally. Right, totally. Right, so like how do you even come up with this, right? That is for sure like really hard. Alright, so I think we can all agree that number 9 is a matter of like you just compute it and then use trig identities and blah blah blah. I'll tell you, in the end you end up with 5 pi. So I will leave that to you guys. Now for number 10. Number 10, the last one, number 10. The integral from 0 to infinity sine x over x squared times this thing is also inside of the integral. So imagine if you expand this, you have infinitely many things that you have to integrate. Right, so this is the final question of the night. By the way, right now it's 9:12 p.m. here. Let me know where you guys are from. How many of you guys are also from the SoCal area or California area in general? And maybe you can also let me know if you are participating in the BMT this year on UC Berkeley campus. And again, you can participate in the online version. They even have a China version. More information will be in the description. They're not sponsoring me. In fact, we are sponsoring them. Right? We make the donation because of my Patreon support and also you guys watching my video. So that's how we are able to make the donation to BMT. And this year, we are actually going to do something really cool. We are going to have they call it the Student Mentor Appreciation Award. So it's to honor the teacher, the coach, or the parent who are leading the competition team. So if you're participating, definitely check that out. We are going to select 3 coaches or mentors or parents or teachers, and then each of them will get $500. So we're honoring and appreciating the hard work, the actual work that those people do. And as a teacher, I totally understand, how hard sometimes is being a teacher, and then it's really cool that we're doing this. So try it and let's see. Oh, Victor, you are going to. That's very cool. This is the last question, so of course it's going to be hard. I'm actually going to zoom in like this because this is the last thing that we are looking at. You learned this stuff over 40 years ago. Too hard for you now, but fun to watch. This is hard. Just hard. It's hard for me too. 10 a.m. in India. Okay. Switch the sum and integral. Okay, if you want to switch the sum and the integral, how would you continue from there though? Because we still have to integrate somehow. You don't need to do Laplace transform. Yeah, it's not the topic right here. Integrating from 0 to infinity looks like Laplace. I agree. It does not have the e to the negative st part though, right? Sometimes they may utilize that integral as like a calculus question. I agree in terms of that. I will tell you for this one, you don't need to know anything about Laplace transform. Okay, let's see. Well, 6 a.m. and you're watching, I'm going back to the chat and then like reading you guys. Okay. 11 a.m. Wow, where that is. And then Pittsburgh, past midnight. Yeah, I was actually going to stream this around like 7 p.m. PST, but was busy. Ontario, California. Oh, past midnight. Oh, wow. Well, thank you guys so much for watching. And then 5 a.m. in London. Wow, that's very early. And then, okay, let's see. Define n is equal to 1. Okay, that's sine x. Okay, that will give you sine square over x squared. That is a pretty famous integral. Yeah. You know, when I first saw this, because of the n factorial on the bottom, that reminds me that we should be doing something with e. Let me see. E to the inx. Take the imaginary part. Oh, is it because of this part, right? And how do we handle this though? You forgot the brutal force evaluation. You can try. Let's see. Yeah, for this one, at least it's computational. If you just compute it and know some techniques, it will work. This sum reminds you of Fourier series. Oh yeah, I agree, because of the nx instead of the sign, right? Can you reparameterize it? Oh, that word is so hard for me to pronounce. Can you reparameterize it? Infinity as u. And then how do we do it from there? Okay, assume convergence. Yes, otherwise, hold on, is that true? I wonder if they ever ask you like a infinite series question and then at the end the question answer is divergence. I wonder if they ever done that. It could though. It could. Yeah. So I can't say if this right here definitely converges or not, but because I saw the answer, I will tell you it does converge. And I think somebody had a very close answer. Oh, by the way, if you saw my post on Instagram or on my YouTube channel, then I think I posted this one not long ago, like a couple weeks ago. You have seen a lot of people swap the sum and integral. Yes, you could totally try that. I'll tell you it does converge, and then you can totally do that. The hard part is to see how to play around with the sin x times sine of nx. This thing right here, I will tell you, based on the official solution, you have to know the trig identity, the product to sum formula. So sine A times sine B, right? You have to figure out an identity for that. That is, yeah, it's hard because I don't have that remembered. Oh, did you just figure that out for number 8? Were you doing number 8 earlier? If so, I'll show you, yes, that is the answer for number 8. That's the answer for number 8. Yeah, and then you can go back to the, like a couple minutes ago for seeing the whole thing. Yeah, cosine A plus B and all that stuff, right? It's like, yeah, I don't have that remembered, so. Oh yeah, 1/2 cosine A minus B, all that stuff. Okay. All right, I want to keep the stream under 1 hour, so like another minute or so. For this one, do you guys want to see the answer, or do you guys want to figure this out? I do want to make a video on this. Are you willing to wait, or do you want to see right now? I'm reading the chat, so depending on what you guys want. All right, I'll see 2 people that you guys want to see the solution. All right, let me know what you think. Yes or no? Do you want to see a solution now or no? You want to see right now? Okay, I think we'll have more people for that. Let me see. I might skip your comment. I don't mean to ignore anybody, but it's just a lot of comments. Yeah. And sorry, in terms of time, here is the solution. Here's the solution. Here's the solution. So you do have to switch the sum and the integral, and you pretty much put this and that together, and then this is what I was saying. You have to break them apart by using the product to sum formula, and then the rest. Yeah, so final answer, pi over 2 times e minus 1. Again, because we have this 1 over n factorial thing again. All right, so that's it for the day. Thank you guys so much for coming. All right, thank you so much for joining the live stream. And maybe I will do another one. I will do a algebra one next time. Let me show you. I did have this printed out, the algebra test. Maybe we'll do it another day. Right? All right, again, thank you guys so much. Thank you. Have a good night if it's evening for you. Have a good day if it's morning for you. Thank you. Bye.